So today's topic of discussion includes some of the sorting techniques like bubble sort, selection sort, insertion sort and merge sort. The idea behind the insertion sort says that we need to start from the second most element and assign it to a variable named as key, and then we need to check all the elements to the left of the key. If the elements to the left of the key is more than the key, in that case all such elements are shifted towards the right, an empty space will be created and the key will be placed in that empty space. For example, for this given array 9, 2, 6, 5 and 3, firstly the key is equal to 2, element to the left of key, that is 9, is more than 6, 9 is shifted towards the right and empty space is created and 2 is inserted in that empty space, and so we are getting the array as 2, 9, 6, 5 and 3. In the second iteration, key is equal to 6, element to the left of key, that is 2 and 9, and from these elements 9 is more than 6, so 9 will be shifted towards the right, an empty space will be created and 6 will be placed in that empty space, and so we are getting the array as 2, 6, 9, 5 and 3. In the third iteration, key is equal to 5, elements to the left of key, that is 2, 6 and 9, and from those elements 6 and 9 are more than the key, that is 5, and so all these two elements are shifted towards the right, an empty space is created and the key will be placed in that empty space, and so we are getting the array as 2, 5, 6, 9 and 3. And in the last iteration, key is equal to 3, elements to the left of key, that is 2, 5, 6 and 9, out of those elements 5, 6 and 9 are more than 3, so these three elements are shifted towards the right, an empty space is created and 3 is placed in that empty space, and at last we are getting the sorted array as 2, 3, 5, 6 and 9. The next sorting technique is known as selection sort. The idea behind selection sort says that we need to traverse throughout the array and find the smallest element and then swap the smallest element with the first element of the unsorted array. Initially the entire array is unsorted. We found a smallest element as 2 and we need to swap with the first element of the unsorted array, that is 9, and so the array is 2, 9, 6, 5 and 3. Now the unsorted array starts from 9 and 2 is already sorted. We'll find the smallest most element, that is 3, and swap it with the first element of the unsorted array, that is 9, and so we are getting the array as 2, 3, 6, 5 and 9. Now the unsorted array starts from 6. We'll find the smallest most element, that is 5, and swap it with the 6, which is the first element of the unsorted array, and so we are getting the array as 2, 3, 5, 6 and 9. Now the unsorted array is 6 and 9. We'll find the smallest most element, that is 6, and swap it with itself, and so at last we are getting the sorted array as 2, 3, 5, 6 and 9. The next sorting technique is known as bubble sort. This traversal might seem a bit longer, but let's first understand the idea behind the bubble sort. We'll start traversing the array from back towards the front, and what we need to check, suppose the current element is equal to 3 and the element before 3 is equal to 5. If the element before a current element is more than that element, in that case we need to simply swap those two elements. For example, for this complete array, we start traversing the array from 3 towards 9 and we found that 5 is more than 3. In that case 5 and 3 are swapped. Now for these cases 3 and 6, 6 is more than 3, so 6 and 3 are swapped, and so on. We'll keep proceeding with the same procedure, and at the last we are getting the sorted array as 2, 3, 5, 6 and 9. Merge sort. The idea behind a merge sort is that we need to keep splitting the array until it is broken into single individual elements. And once it is broken into single individual elements, we need to keep merging them, we need to keep adding them, while keeping in mind the array so formed should be in the sorted order. For example, for this same array 9, 2, 6, 5 and 3, this was the complete array. It was split into two parts, 9, 2, 6, 5 and 3, simply from the formula. Here starting index p is equal to 0, ending index q is equal to, ending index r is equal to 4, and so the mid is equal to 0 plus 4 by 2, that is 2. That is the elements 0, 1, 2 in the first pair, elements 3 and 4 in the second pair. And so 9, 2, 6, 5, 3 got split into 9, 2, 6 and 5, 3. Similarly, this entire array is split into 9, 2, 9, 2 and 6, and 5, 3 into 5 and 3. And further 9, 2 is also split into 9, 2 and then 6, then 5 and 3. So after this division phase, I am getting these separate elements of the array as 9, 2, 6, 5 and 3. Now for the merging phase, the array so formed should be in the sorted order. And suppose we are merging 9 and 2, we'll merge them and sort them at the same time, so it becomes 2 and 9. Similarly for 5 and 3, we'll merge them as 3 and 5. We are merging and sorting at the same time. Now 296 is merged as 269, and 53 was merged as 3 and 5, and this 269 and 3 and 5. These two sub arrays are merged as 2, 3, 5, 6 and 9. So this was a phase of division and this was a phase of conquer, and at last we are getting the sorted array as 2, 3, 5, 6 and 9. Now these are certain sorts of complexities, that is best case and worst case complexity. For example, for the insertion sort, the best case is big O of n and the worst case is big O of n square. For the selection sort, it's big O of n square and big O of n square. For the bubble sort, it's big O of n and big O of n square. For this merge sort, it's big O of n log n, big O of n log n, and the same for the remaining sorting techniques.